In this video, we'll use a trigonometric substitution to evaluate the indefinite integral of 1 over x squared times the square root of x squared minus 1. We'll assume that our variable is being integrated over some interval where x is bigger than 1. When I look at the expression that's under the radical, the square root of x squared minus 1, I'm reminded of the trigonometric identity secant squared of theta minus 1 is tangent squared of theta. That suggests to me that I should let x equal secant of theta, thinking about the secant squared pairing with the x squared minus 1, and we want to replace it with some expression involving tangent squared of theta. What I'm really doing is declaring a new variable theta, and that variable is the arc secant of x. We're going to differentiate x as a function of theta to find the differential, so dx will be secant of theta, tangent of theta, and writing it as a differential, bringing the d theta to the right hand side, we get dx is secant of theta times tangent of theta d theta. We can keep track of the relationship between our new variable theta and our old variable x by drawing a little right triangle here. I've drawn theta as one of the angles. I'm declaring the secant of theta to be x. That means the cosine of theta is 1 over x. And cosine is adjacent over hypotenuse. So I'm going to label the adjacent side 1 and the hypotenuse x. The remaining side then, which is missing over here, using the Pythagorean theorem, can be found to be the square root of x squared minus 1. Observe that that side is precisely the expression that motivated the substitution in my integral. We're now ready to carry out the substitution. I have x squared times the square root of x squared minus 1 in the denominator. Every instance of x should be replaced with a secant of theta. So I'll have secant squared of theta here. Don't forget to carry out the substitution for the differential. Dx is dx equal to the secant of theta times tangent of theta, and so that should appear in my numerator as well. So rewriting things, in the numerator I have my differential term, the secant of theta tangent of theta d theta. In the denominator I have secant squared, and then under the radical I have secant squared of theta minus 1. That will get replaced with tangent squared of theta. When I simplify the square root here, the square root of a square will be the absolute value of that expression. And so I'm careful here to note that it's the absolute value of tangent when I simplify. However, when I'm looking at values of x that are bigger than 1, and I take the arcsecant of that value of x, your calculator, if you put in a positive number, something bigger than 1, and hit the arcsecant button, it will give you something in the first quadrant, something between 0 and pi over 2. As a consequence, my angle theta will be in the first quadrant, and therefore the tangent of theta will be something positive. And I really don't need these absolute value bars by virtue of the fact that I'm assuming that x is bigger than 1. Therefore the tangents will cancel out exactly, and the secant will cancel with one factor of secant in the denominator, and I'll be integrating 1 over the secant of theta. The reciprocal of theta is cosine of theta, so I'm really just integrating the cosine of theta. The antiderivative for cosine is sine, and now I need to back substitute and return to an expression involving only x. I look at the relationship in my triangle here. Theta, the sine of theta, is the opposite over the hypotenuse. The opposite is the radical expression, square root of x squared minus 1, and we divide by the hypotenuse, which is x, and we've completed the integral. This expression is the antiderivative of my original expression.